All right, so today's lesson, again, is going over solving systems that are nonlinear systems. When we're doing these, we want to use the substitution method. So you're going to take one of those equations. If it's already solved for one of the variables, it makes your life a lot easier. If it's not, use one of the two, solve for one of the variables, then plug in and simplify. You're going to have two ordered pairs for each of these at least. If we look at number 1, we have x plus y is equal to 2 and y is equal to x squared minus 4. This, we already have that y is equal to the x squared minus 4. So we're going to take that x squared minus 4, we're going to plug it in for y in the first equation. So we're going to have x plus x squared minus 4 is equal to 2. We have an x squared in that equation, so we want all of our terms on the same side. We're going to move the 2 over by subtracting it from each side. We have x squared plus x minus 6 is equal to 0. From here, you want to find the factors of that negative 6 that add up to 1 in order to factor this. If we have a negative 2 and a positive 3, that gives us the positive 1 that we're looking for. So this factors out to be x minus 2 times x plus 3 is equal to 0. Now that we're factored, we're going to set each part equal to 0. So we're going to have x minus 2 is equal to 0 and x plus 3 is equal to 0. Solve for x for both of these. Add your 2 to each side. You get that x is equal to 2. Subtract your 3 from each side. You have that x is equal to negative 3. From here, you are going to plug both of these numbers in for x in one of those original equations and solve for y. I'm going to use the top one, so I'm going to have 2 plus y is equal to 2, as well as negative 3 plus y is equal to 2. I move the 2 over by subtracting it from each side, and I get that y is equal to 0. I move the 3 over by adding it to each side, and we get that y is equal to 5. So again, you have two ordered pairs that are your solutions. One is 2, 0. The other is negative 3, 5. The next example that we're going to look at is number 3, which is just x plus y is equal to 2, and y is equal to x squared minus 4x plus 4. Now, we do have a y is equal to here. So if we just take that entire expression of that x squared minus 4x plus 4 and plug it in for y in that first equation, we're going to have x plus x squared minus 4x plus 4 is equal to 2. We have an x squared. Combine your like terms on that same side and move that 2 over. To move the 2 over, we're going to subtract it from each side. The x and the negative 4x are like terms, so we're also going to combine that. So we're going to have x squared minus 3x plus 2 is equal to 0. Your factors of 2 that add up to be negative 3 are negative 1 and negative 2. So this is going to factor to be x minus 1 times x minus 2 is equal to 0. We set each of these equal to 0 and we solve. We're going to move the 1 over by adding it to both sides. So we have that x is equal to 1. Add your 2 to both sides also, and you get that x is equal to 2. So you're going to use one of those two equations, plug in the 1 for x, solve for y, then plug in the 2 for x, solve for y. I'm going to use the top equation, so I'm going to have 1 plus y is equal to 2, and 2 plus y is equal to 2. We're subtracting the 1 from each side to get y is equal to 1, and we're subtracting the 2 from each side to get that y is equal to 0. So your two solutions here are 1, 1, and 2, 0. Next, we're going to look at number 7. We have x squared plus y squared is equal to 25, and x minus y is equal to 1. I'm going to take that x minus y is equal to 1 and solve that for x. So I'm just going to add the y to both sides and we get that x is equal to y plus 1. If x is equal to y plus 1, we're going to plug that y plus 1 in for x in the opposite equation. So we're going to have y plus 1 squared plus y squared is equal to 25. That y plus 1 squared is y plus 1 times y plus 1. So you're going to have to FOIL this out in order to get what y plus 1 raised to the second power is. When you FOIL this out, you're going to have y squared plus 2y plus 1 plus y squared is equal to 25. Combine your like terms, move the 25 over by subtracting it from each side. You're going to be left with y squared plus, 2y squared plus 2y minus 24 is equal to 0. Factor this left side as much as you possibly can. You do have a greatest common factor between all three of these terms, so we're going to factor out a 2, and this is going to give us 2 times y squared plus y minus 12 is equal to 0. Your factors of negative 12 that add up to be a positive 1 are negative 3 and positive 4. So this is going to factor, this is going to be factored to be 2 times y minus 3 times y plus 4 is equal to 0. Again, we're going to take each part, set it equal to 0. So y is equal, or y minus 3 is equal to 0, y plus 4 is equal to 0, and 2 is equal to 0. That 2 is equal to 0 is a false statement, so do not work with it. Forget about it. The y minus 3 is equal to 0. We'll add 3 to both sides. We have that y is equal to 3. Y plus 4 is equal to 0. We subtract the 4 from each side, so y is equal to negative 4. We still need to find for x. You can use that x is equal to y plus 1 in order to plug in the 3 and the negative 4 and solve for x. So if we do that, we have x is equal to 3 plus 1, and x is equal to negative 4 plus 1. From here, that x plus 3, or that 3 plus 1 is going to give us that x is equal to 4. So that gives us 3, 4. Then you also have negative 3 for an x, so that one is negative 3, negative 4. So for the next one we're going to look at 15. We have x plus y is equal to 1, and x squared plus xy minus y squared is equal to negative 5. For this one, we are going to solve with that x plus y is equal to 1. We're going to move the y over by subtracting it from each side. We get that x is equal to negative y plus 1. So everywhere we see an x, we are going to plug this negative y plus 1 in. So this is going to be negative y plus 1 squared plus negative y plus 1 times y minus negative y plus 1, negative y, just minus y squared. Minus y squared is equal to negative 5. From here, multiply. You know that you can distribute that y into the negative y plus 1. That negative y plus 1 squared is going to have to be rewritten as negative y plus 1 times negative y plus 1. This is going to give us negative y squared plus y minus y squared is equal to negative 5. I'd FOIL your negative y plus 1 times negative y plus 1. We're going to get y squared minus 2y plus 1. You can move that 5 over and combine like terms at the same time. So we're going to add the 5 to each side. Your like terms are the y squared minus y squared, which cancels out. Then we also have that negative y squared. The negative 2y and the y give us a negative y. And then 1 plus 5 gives us 6. From here, I want to factor out a negative 1, so that way I'm not working with a negative y squared. So this is going to just be negative, or the opposite of y squared plus y minus 6 is equal to 0. We're going to factor this. Your factors of 6 that add up to be 1 are 2 and 3. If the 2 is negative, the 3 is positive. That gives us a positive 1. So this factors to be the opposite of y minus 2 times y plus 3 is equal to 0. Set each part equal to 0 and solve for each. That negative 1 is equal to 0 is a false statement, so do not work with it. Add your 2 over to get that y is 2. Add your 3 over, subtract your 3 over to get that y is equal to negative 3. We said that x is equal to negative y plus 1. So to solve for x, we can plug in the 2 and the negative 3. So we're going to have the opposite of 2 plus 1 and the opposite of negative 3 plus 1. This is going to give us x is equal to negative 2 plus 1 and x is equal to 3 plus 1. Negative 2 plus 1 is negative 1. 3 plus 1 is 4. So this gives us negative 1, 2, and 4, negative 3. The last example that we're going to look at is number 21. For this one, we have x squared minus 4y squared minus 7, as well as 3x squared plus y squared is equal to 31. If we want to use elimination for this, we can, since we both equations have an x squared, both equations have a y squared. What we can do to eliminate this, your y values are opposites. So if we multiply the last equation by 4, this is going to give us x squared minus 4y squared is equal to negative 7, as well as 12x squared plus 4y squared is equal to 124. If we add these, we're just combining like terms, we get 13x squared, those y's cancel out, is equal to 117. From here, we can divide each side by the 13, and we get that x squared is equal to 9. You want x, not x squared. So take the square root of both sides, and you get that x is equal to negative 3, as well as x is equal to 3. From here, solve for y for both of these. I would use the top equation just because it's a little bit easier. You're working with smaller numbers, that's all. So if I do that, I'm going to have negative 3 squared minus 4y squared is equal to negative 7, as well as 3 squared minus 4y squared is equal to negative 7. From here, we are going to have 9 minus 4y squared is equal to negative 7. 9 minus 4y squared is equal to negative 7. Then we're going to move the 9 over by subtracting it from each side. So we get negative 4y squared is equal to negative 16. And that's for both of these. We divide each side by the negative 4. Again, for both. And we get that y squared is equal to 4 for both of these. So we're going to take the square root of both sides. This gives us y is equal to plus or minus 2. Same thing for this one. So we're actually going to have 4 solutions for this. For the one on the left, we have negative 3, negative 2, as well as negative 3, positive 2. For the one on the right, we have positive 3, negative 2, as well as positive 3, negative 2. Positive 2.